Ladies and gentlemen, welcome to MyJ ChemTalk. My name is Kevin Lee, MyJ Asian Pacific Marketing Manager, and I'm honored to host such a grand event. As you know, MyJ is committed to innovative medical solutions. Together, we have experienced 2020 such a fantastic year. Regardless of the result, this is an unforgettable year for everyone. Even now, COVID-19 is still a pandemic in most countries. Some Chinese may explain this way. According to the traditional lunar calendar, 2020 is a year of a rat, so we should reduce the time of outdoor activities. However, 2021 is a year of ox, which means strong and work hard. In addition, we use bull market to indicate strong growth in stock. In any case, 2021 means hope. Therefore, we hope to get out of the shadow of COVID-19 early 2021, recover from the long winter, and start planting seeds. Clinical chemistry is widely used in almost every laboratory. We MyJ is the first research and manufacturer of clean chemistry system in China, and our brand has been widely recognized by customers from more than 100 countries on all inhabited continents. Based on the rapid development of our business, we continuously invested in clean chemistry product line, and now we have extensive product portfolio from benchtop analyzer to scalable module systems. We produce original reagents to ensure better traceability and reliable results. We continue to develop intelligent and user-friendly software to help laboratories maximize efficiency and minimum TAT. We have ranked #1 in China. Our market share in 2020 has surpassed Roche, Apo, Visa, and Siemens. This is the first time we organize ChemTalk, a professional webinar focusing on clean chemistry. Maybe you have heard of a HemaTalk of MyJ, which focuses on clinical application of hematology products. Yes, we have same concept. We will invite more professors to join ChemTalk to share innovative technology and application experience. Your case studies are also very valuable. Please contact us if you want to share on the ChemTalk platform. Today, we are very glad that we have invited Professor Chen Xinqi, who came from the top-level hospital in China, and Professor Nawampan Chararas. She is the talent quality consultant at National Blood Center. I'm very sure all of us can get some new ideas during their sharing. Professor Chen Xinqi is Associate Professor, Deputy Chief Physician of Clinical Laboratory Department of Peking Union Medical College Hospital. He is ISO 15189 Medical Laboratory Accreditation Assessor, standing member of Laboratory Immunoassay Analyzing Committee in China Association for Instrument Analysis, and standing member of the Chinese Society of Clinical Oncology Thyroid Cancer Expert Committee. Today, his topic is clinical chemistry lipid panel from results validation to items application. Welcome, Professor Chen.
Hello, everyone. I'm Chen Xinqi from the Laboratory Department of Peking Union Medical College Hospital. I'm honored to be here to share some of my experience in choosing and applying lipid test items with international pathologists. My title is Clinical Chemistry Lipid Panel from Results Verification to Items Application. My lecture is divided into 4 parts: interpretation and thoughts on lipid test results, common items in lipid monitoring tests, clinical application of lipid tests, and analysis of difficulties in interpreting lipid test results. First, let's talk about how lipid test results are interpreted, and I'll share some thoughts on this aspect. Here are 4 different patients' lipid profile test results. The test items include total cholesterol, triglyceride, high-density lipoprotein cholesterol, and low-density lipoprotein cholesterol. What problems can we see from the lipid profile test results of these 4 patients? Firstly, let's look at the reference intervals of LDL-C. Why are the reference intervals of LDL-C different among different populations? According to Friedewald formula, total cholesterol can be calculated using the test results of TG, HDL-C, and LDL-C. So the second question is, why is there such a difference between the measured and calculated total cholesterol in these 4 patients? How is total cholesterol distributed in different lipoproteins in the tested blood samples? Here are the lipid monitoring test results of another patient who has attracted our attention. The lipid test results are normal in this patient, except for an increase in Apo B. LDL-C level is normal, but Apo B is increased. What does this mean? Before answering these questions, I'd like to introduce the common items in lipid test first. Triglyceride, total cholesterol, low-density lipoprotein cholesterol, high-density lipoprotein cholesterol are the most commonly used in clinical lipid monitoring. Apart from these items, 2 apolipoproteins, Apo A and Apo B, are also among the common items in lipid monitoring tests. In addition, lipoprotein little a, small and dense low-density lipoprotein cholesterol, homocysteine, and hypersensitive C-reactive protein are also tested in clinical practice. In order to understand these test items, we must first understand what lipoprotein is. Lipoprotein is the complex of lipids and proteins. It has a spherical structure with a core of hydrophobic cholesterol ester, free fatty acids, and triglyceride. The lipoprotein surface contains hydrophilic cholesterol, phospholipids, and apolipoproteins. In short, lipoprotein is the complex of lipids and proteins. Different lipids and proteins carried in different lipoproteins vary in type and quantity. On this basis, lipoprotein can be classified as different types, including chylomicron, very low-density lipoprotein, low-density lipoprotein, and high-density lipoprotein. Therefore, TG and TC levels are the total contents of triglyceride and cholesterol carried in different lipoproteins. The measured levels of Apo A and Apo B are apolipoproteins on the lipoprotein surface. Lipoproteins contain different types of lipids and proteins, so they are difficult to measure directly. To date, there are no conventional methods that can accurately measure lipoproteins. Generally speaking, the cholesterol contents of LDL and HDL are stable. Therefore, the cholesterol content of the lipoproteins is usually used as the basis for measuring lipoproteins. For example, when high-density lipoprotein cholesterol is determined, different methods can be used to remove other lipoprotein components, such as chylomicron low-density lipoprotein and very low-density lipoprotein, and all that's left is high-density lipoprotein. Then the cholesterol concentration is determined by the enzymatic method to represent the high-density lipoprotein concentration. Likewise, the direct method of low-density lipoprotein cholesterol shares a similar detecting principle. That is, the low-density lipoprotein is preserved, and then the cholesterol is measured. Besides the direct method, LDL-C can also be calculated using the Friedewald formula. However, it should be noted that different units of Tg should use different calculation formula. The Friedewald formula can be applied to calculate the LDL-C level, although it should be noted that this formula is applicable only under the following three conditions. That is, there is no chylomicron in fasting plasma. Tg level is less than 4.6 millimole per liter, and except for type 3 hyperlipoproteinemia. Some Chinese scholars have evaluated the comparability of LDL-C levels calculated using the formula and the levels obtained via the direct method. The results indicated significant differences in the LDL-C levels calculated using the 5-point formula and that obtained using the direct method. The deviation ranged from -3.11% to -8.15%. Therefore, the direct method is recommended for measuring the LDL level. The direct testing method is recommended in the guideline for the management of dyslipidemia in Chinese adults to determine LDL-C and HDL-C levels. Apo A and Apo B are respectively the major polyproteins of HDL and LDL, and they are positively correlated to HDL and LDL levels. Therefore, they can reflect HDL and LDL levels respectively. However, especially in patients with family hypercholesterol, a significantly elevated Tg level, and diabetes, the cholesterol contents of HDL and LDL may be unstable. In those patients, Apo A and Apo B tests may be needed in addition. In disease, the level of LDL-C is not necessarily proportional to the number of lipoprotein particles. For example, in these two patients, patient 1 has larger lipoprotein particles, and patient 2 has smaller lipoprotein particles. Although LDL-C levels of these two patients are the same, the LDL particles of patient 2 are small, but the number of particles is higher, so the level of Apo B on the surface of LDL particle is increased. Compared with patient 1, the risk of cardiovascular events for patient 2 is higher. Now, let's return to the above patient. Although the patient's LDL-C level is normal, but Apo B is elevated, which indicates an increase in the number of LDL particles. Doctors should pay more attention to this patient's lipid profile. Another lipid indicator closely related to cardiovascular disease is lipoprotein little a. Lipoprotein little a is closely related to the genetic factors and should be tested at least once in a lifetime. If an elevation of lipoprotein little a is indicated, patients should receive relevant treatment and be monitored in the future. Let's move on the third part, the clinical application of lipid test. Patients visiting the outpatient clinic and emergency department being admitted to the hospital and receiving physical checkups may all have requirements for lipid monitoring tests. Accurately testing blood lipid levels can help doctors evaluate the risk of cardiovascular and cerebral vascular diseases. Hypertension, hyperlipidemia, and hyperglycemia may occur concomitantly. The Chinese Survey of Important Cardiovascular Disease shows that the prevalence of only dyslipidemia is about 41%. The prevalence of hypertension combined with dyslipidemia is about 40%. The prevalence of diabetes combined with dyslipidemia is about 53%. It is necessary for patients with diabetes to monitor their lipid profile regularly. As many as 53% of patients who with diabetes also have dyslipidemia. But in China, only 27% of patients with diabetes know that they also have dyslipidemia. Therefore, it is necessary for all patients with diabetes to have their lipid profile monitored regularly. Chronic kidney disease patients usually also suffer from dyslipidemia, which presents with an increase in TC, LDL-C, and Lp(a), and a decrease in HDL-C. At an early stage of chronic kidney disease, the LDL-C level is correlated more significantly with myocardial infarction. Therefore, lipid profile monitoring should start in the early stages of chronic kidney disease. The functional status of thyroid is closely related to metabolic indicators such as blood lipids. In outpatient clinics, hypothyroidism combined with dyslipidemia is very common. Hypothyroidism may present with an increase in TC, LDL, and Apo B levels, and a decrease in the HDL level. Clinical hypothyroidism can affect the metabolism more significantly than subclinical hypothyroidism. Thyroid hormones affect almost every aspect of lipid metabolism, including synthesis, transportation, and degradation. Serum TSH level more than 10 millunit per liter is correlated with elevated serum cholesterol. Each increase of 1 millunit per liter in TSH level can cause a cholesterol increase of 0.09 millimole per liter in female and 0.16 millimole in male, respectively. Among emergency patients, acute pancreatitis usually need a TG test. Elevated TG is closely related to acute pancreatitis. The probability of patients with hypertriglyceridemia having acute pancreatitis is 12 to 38%. Elevated TG may aggravate the inflammatory response. Therefore, it is necessary for patients with hyperlipidemic acute pancreatitis to have their TG level reduced to below 5.65 millimole per liter as soon as possible. The TG level is closely related to the prognosis of acute pancreatitis. Therefore, it is necessary for acute pancreatitis patients to have TG tests. When TG increases, it is necessary to treat and make triglyceride levels decrease rapidly. Physical examination are an important way to detect this lipidemia. Early detection of this lipidemia and monitoring changes in blood lipid levels are an important basis for the prevention and the treatment for cardiovascular disease. It is generally recommended that the population aged less than 40 years old should have a lipid monitoring test once every 5 years. For males aged more than 40 and postmenopausal women, lipid monitoring tests should be carried out once a year. For cardiovascular disease patients, the high-risk populations, lipid monitoring tests should be carried out once every 3 to 6 months. Patients who are hospitalized due to cardiovascular disease should have lipid monitoring tests before admission or within 24 hours of admission. Blood lipids are related to a variety of metabolic disorders and may occur secondarily to other diseases. At present, lipid monitoring tests are generally given as a part of the pre-admission screening examination. Lipid monitoring tests can be used to determine the lipid levels of patients, assess the severity of disease, and help choose an individualized lipid-lowering therapy. The results of several meta-analyses have shown that statins decrease TC and LDL-C levels, reducing the risk of cardiovascular disease by 25 to 35%. Finally, let's look at difficulties in interpreting the results of lipid monitoring tests. When interpreting lipid monitoring test results, choice of reference interval is critical, especially for LDL-C. The reference intervals of LDL-C levels should be chosen on an individualized basis for different populations. For example, the reference intervals of LDL-C levels vary for the normal population, high-risk population, and the population at extremely high risk. The goal set for the LDL-C level is the most strict for the population at extremely high risk, for whom the target LDL-C level should be lower than 1.8. For the high-risk population, it should be lower than 2.6. And for other populations, it should be lower than 3.4. Moreover, non-HDL-C is an optional indicator. It's generally believed that non-HDL-C is the most important predictor of cardiovascular risk apart from LDL-C. TC level minus HDL-C level is the non-HDL-C level. Therefore, it is very important to accurately detect the TC, LDL-C, and HDL-C levels. During the risk evaluation of individuals, CVD patients are directed as extremely high risk. Patients are directly classified as high-risk populations if they meet one of the following criteria. The first one is LDL-C level more than 4.9 millimole per liter. The second one is diabetic patients with LDL-C level higher than 1.8 millimole per liter and lower than 4.9 millimole per liter and aged 40 years old and above. Other factors considered in the risk stratification are gender, age, blood pressure, BMI, smoking, non-HDL-C, HDL-C, and so forth. Standardization and accuracy of lipid monitoring tests are also highly important for interpreting results. The most commonly used blood lipid tests are 4 items, namely total cholesterol, triglyceride, LDL-C, and HDL-C. If non-HDL-C is reported, the same detection system and the same brand of reagents must be used to test 4 items of blood lipid. Besides, considering the logical relationship between TC, LDL-C, and HDL-C, it is recommended to use the same detection system and the same brand of reagents. We have evaluated the logical relationship between TC, HDL-C, and LDL-C using reagents from different manufacturers. The occurrence rate of HDL-C plus LDL-C more than TC using reagents from different manufacturers varied significantly. The highest rate was 7.8 thousandths. The lowest rate was 0.44 thousandths. The occurrence rate using Mandarin reagents was below 1 thousandth. In addition, when HDLC plus LDLC are much smaller than TC, we need to consider the accuracy of LDLC and the distribution of cholesterol in different lipoproteins. Besides detecting TG, TC, LDLC, and HDLC, we can also find out the components of lipoproteins in patients using lipoprotein electrophoresis. The picture of the electrophoresis can clearly show the components of lipoproteins, such as the levels of CM, VLDL, LDL, and HDL. The distribution of cholesterol in different lipoproteins can also be analyzed using lipoprotein electrophoresis. In samples number 10 and number 13 in the figure, cholesterol is not only distributed in LDL and HDL, but also in VLDL. This also explains why the TC level of some patients is much greater than the sum of the LDLC and HDLC. The Framingham Heart Study found that some coronary heart disease patients had normal levels of TC, LDLC, HDLC, and TG. Therefore, besides the common lipid indicators, we should also pay attention to the residual risk of routine lipid profile. According to some international guidelines, the major cardiovascular disease risk factors include LDLC, SD-LDL, Lp(a), coagulation function, inflammatory markers such as high sensitivity C-reactive protein and homocysteines. And LDLC is the most important risk factor. Pathologists should pay attention to the verification of lipid test results and the clinical significance of each test atom, and understand lipoprotein structures, functions, and metabolism. Clinicians should select the lipid atoms on an individualized basis, depending on the features of different disease. Both pathologists and clinicians should focus on the application of different lipids testing methods and the information provided by the test results. So that's all. Thank you for listening.
Thank you, Professor Chen. The application of lipid panel is becoming more and more common. It's necessary to know more about the clinical interpretation. Moreover, we should follow Professor Chen's suggestion, pay more attention to our lipid panel monitoring. Okay, now is a Q&A session, and we collect some questions from the chat box. The first question to Professor Chen is, in what situation LDL's result calculated by formula may not be reliable? How can the laboratory improve the reliability of LDL results under these situations? Professor Chen, could you answer this question?
Yeah, okay. Thank you the question. And in my opinion, I think in some situations, for example, when there is CM in fasting plasma or TG level is more than 4.5 millimole per liter, or lipoprotein little a is higher than 400 milligram per deciliter, or type 3 hyperlipidemia and some serious kidney disease or treatment in CVD or drug interference. Sometimes in these situations, the LDLC result calculated by formula may not be reliable. And I think in these situations, we should measure the LDLC level directly. Yeah, thank you.
Thank you, Professor Chen. Also, we have the second question from chat box is, according to the presentation, the occurrence rate of HDL plus LDL more than cholesterol and HDL plus LDL less than 1.5 times of total cholesterol is open system with a third-party reagent is higher than closed system with the original reagent. So what is the reason of this phenomena? Professor Chen, could you answer this question?
Yeah, I think it's a good question. But in my opinion, I think it is not absolute. And sometimes, the occurrence rate of this illogical relationship in open system with third-party reagent is lower than closed system with original reagent. So it depends on the reagent we use. So the laboratories should select the reagent which has good traceability or good comparability with reference methods. In addition, the performance of the reagent should be fully validated before selecting. Yeah.
Thank you, Professor Chen. And we have the, okay, because of the time limited, so we have the last question from chat box. In what situation Apo A and Apo B tests are recommended? Please, thank you, Professor Chen. This is the last question.
Okay. It depends, and we can refer to the guidelines of different countries. Some studies have shown that Apo B is a potential and good indicator for evaluation and monitoring for CVD disease, especially that small and density LDL is the main content of LDL particle. As we know, it is difficult to measure lipoproteins directly, and we use cholesterol in HDL and LDL to represent the level of HDL and LDL particle. But in patients with family hypercholesterol and diabetes, or TG level is elevated significantly, the cholesterol contents of HDL and LDL may not be stable. At this time, Apo A and Apo B tests are recommended in addition. Yeah, thank you. This my answer for this question. Yeah.
Thank you very much, Professor Chen. I think your sharing help us understand more about the lipid panels. Okay, now is the second speaker. Professor Nawampan Tararaks came from Thailand. She is quality consultant at National Blood Center, Thai Red Cross, and the laboratory and Department of Laboratory Medicine, Faculty of Medicine, Chulalongkorn Kong University, has been the first laboratory in Asia to achieve ISO 15189 in April 2024, when she was the head of Department of Laboratory Medicine, and also in laboratory division. Burma Grand International Hospital has been the first private laboratory in Thailand to achieve the CAP in 2016, when she was the director of laboratory division. So welcome, Professor Nawampan.
It is almost 5 p.m. In Bangkok. So good evening, ladies and gentlemen. It is my pleasure to have this opportunity to present you the key points in ISO 151X9 and 15190. In fact, there are several shells or requirements in 151X9 and 15190. However, I cannot discuss with you for these all shells or requirements today because of we have limitation of time, and I think it's a bit boring to do that. So I just pick up you some key points in ISO 151X9 and 15190, and hope that it will be useful for you when you implement this quality management system in your laboratory, and hopefully that you will implement the system easier and with your confidence. I would like to discuss that I received an honorarium for this presentation, and the presentation provided here is for educational purpose and shall not be shared without my permission. When you are looking for the QMS to implement in your laboratory, usually in every country, you will have a quality management system as a local level and the international level. This slide shows you the example in Thailand. For the local quality management system, we have what we call LA or laboratory accreditation. This quality management system is run by Medical Technologies Association of Thailand. And you see that we also have RCPT checklist. This one is run by the Royal College of Pathologists of Thailand. For international quality management system in Thailand, for the medical laboratory, exactly ISO 151X9 and 15190 is very famous. And you also may have ISO 22X70 for your point of care testing, or for your laboratory that the reference laboratory. You may consider to implement 17025 and 15195. Or for your service, you may consider to implement ISO 9000. However, for the big hospitals, such as the medical school and research laboratory and some big private hospitals, they may consider to implement CAP or College of American Pathologists. And I think there is a key question that's very important for you when you would like to implement the quality management system, and you should answer these three questions. These three questions is about, are you and your team ready? Do you know about quality management system that you want to implement? Do you have resources enough to proceed? This key question is confirms about your commitment, your understanding, and your resources. This is very important. And if your answer is all yes, you have a very great chance or very high confidence that you will get the success when you want to implement the quality management system. Look at the ISO 151X9. There are two major requirements. One is a management requirement, and the second one is the technical requirement. In management requirement, there are 15 requirements, and these 15 requirements focus on two important things. One is about the organization management, and one is about the CQI. For the organization management, they will focus about the organization structure, the quality document structure, quality manual, and document control. And for the CQI, they will focus about the corrective and preventive action evaluations and review, and exactly the CQI. For the technical requirement, there are 10 requirements, and these 10 requirements are focused on personnel issue, accommodation, and environmental condition. This one is about the safety, and exactly the safety that present in this 151X9 is just a limit of the safety level. So that's why when you want to implement the safety requirement, they recommend you to implement the 15190, which there is a 16 requirement that cover all the safety aspect for the medical laboratory. And for another focus in technical requirement is about the laboratory analytical process. We start from pre-analyticals, analyticals to post-analytical process, specimen and sample management, and laboratory information system. So we go to the first key point. It's about the organization structure. It's quite important that you should understand that organization management chart or structure is not the quality management chart. It's not equal. For the organization management chart, you will set the organization structure as your organization requirement. So usually it is a top-down chart which apply from CEO or top leader down to the leader team, to the functional management level, and to the operational team. The purpose of this organization management chart is to drive the organization to achieve the business target. For the quality management chart, you have to follow the quality management system requirement. They require you to demonstrate the quality structural relationship of your quality management team, your quality manager, your laboratory safety officer, and the team in the organization. And the purpose of this quality management structure is to achieve the quality performance, which aim to get the accreditation or certification. And this is the example about the quality management chart. You see here it starts from the organization leader down here to the quality management team, quality manager, and under the quality manager, you may have the quality assurance, quality control, laboratory safety officer, and then all the team in organization. And I would like you to notice that this is a two-way communication. So even laboratory safety officer can also discuss the problem up to your organization leader, or even up to the quality management team. And this one is the example from a company that they combine the quality management structure with the organization management structure. And you can see here that in the blue line is the organization structure from the CEO down to the laboratory director, to the manager, and to the analyst. And for the last line is the quality management structure line. And you will see the relationship of laboratory safety officer, manager, quality manager, laboratory management team, to the director and the CEO. So this is just the example to make you understand the meaning of this structure. For the point number 2, I would like you to notice about the quality document. Usually there are 4 levels of the document, and the first level is the quality manual. The second level is the quality policy or plan. The third level is a standard operating procedure or work instruction. And the fourth level usually is a supporting quality document. It may be come with a form, record, or even guide file, and etc. that you may see. However, the important points to concern about the quality document is to establish and maintain the quality manual and policy, and implement and maintain document those cover all laboratory activity or processes. And you also have to do the periodical reviews, and only update documents are available as work area. And I think the very important things about the ISO is you have to write what you do and then do what you write. So this is a very important that you have to keep in mind for the document. The key point number 3 that I would like to mention here is about problem solving and the continuous quality improvement. The importance of here is about what and how. What is about the identification. You have to identification the problem, which you can identify from complaint, from non-conformity, from KPI, from your first party or internal audit, from your second party audit, for your third party audit, and your management review. And how is about how you deal with the problem to get the CQI. So it's about the corrective action, preventive action. And how you do the preventive action, you have to go to the root cause analysis. So root cause analysis is the important of this part. From correction, corrective action, preventive action, and root cause analysis. This will help you to get the CQI for your quality in your laboratory. And this slide, I just would like to give some example about the common root cause analysis tool for you to understand. The famous one that we are using currently is 5Y. 5Y is the way that you try to dig deeper to find the root cause by ask question, ask until you can dig into the root cause. So this one is great for when you deal with the personal problem. And fishbone diagram, this one is great for the process. If you have the problem about the rejection of sample that's correct to the laboratory, maybe you can just look at the process that it might be the problem of the technique of correction, or problem from the instrument, or even problem from personnel that may be about the training or something. So this is just the example. For brainstorming, it's great if the problem is may occur between or amongst at least 2 units or 2 divisions in your laboratory. So you have to get all personnel involved in this problem to discuss and find the solution together. So this is the example. You also may use the process mapping or FMEA or etc. For the technicals, I would like to start by the laboratory process, because the technical is involved this part. So we start by the pre-analytical, analytical, and post-analytical process. You will see that it involves the technical requirement, start from the 5.1 about the personnel, 5.2 about the accommodation and environmental conditions, 5.3 about the laboratory equipment, reagent, and consumable, 5.4 about the pre-examination process. And for the analytical process, it involves the requirement 5.5 is about the examination processes. 5.6 about the ensuring quality of examination result. And for the post-analytical process is involved 5.7 about the post-examination process, 5.8 about the reporting of result, 5.9 is about the receipt of result, and 5.10 is about the laboratory information management. And if you look it a little bit deeper, you will see that in 5.1 it involves your job description, job specification, training, competency. And 5.2 is about the safety. 5.3 is about the equipment selection and maintenance. And 5.3 is about testing request, sample correction, and management. And 5.5 is about the method selection or test selection, about the verification, validation, uncertainty of measurement, reference interval, and work instruction. And 5.6 is about the internal quality control, external quality assessment scheme, and your alternative approach, your laboratory performance, and comparability of the examination result. And 5.7 is about your result verification. 5.8 is about your result report. 5.9 is about result release. And 5.10 is about your laboratory information management. So look to the key point number 4 is about the personnel management. That's when you hire some people to do the job in the laboratory, you have to have the personnel qualification for that position, and also the job description. And also you have to do the training, the competency assessment, the performance review, and continuing education. So go a bit more to the instrument management. It is important when you want to have a test or instrument in the laboratory, you need to set the clearly objective and then select the test or the instrument regarding to your objective. And also when you implement, you have to do the calibration and method validation, verification, uncertainty of measurement. You also need to have the plan about the maintenance and repair plan. Also, you have to have reagent and consumable management. And this is the example of method verification or validation. And this slide is written regarding to the CLSI or Clinical and Laboratory Standard Institute. Then this is just the example. In different countries, it might be different because of the law and regulation in each country. However, this example, you will notice that when you select or you already have the method that you want to implement into your laboratory, you should classify your test to be web test and non-web test. Web test is a test that easy for performance, easy to when you want to run the test, and also effects to the patient not so much. The good example of web test is a glucose meter. And what you should do for the method verification for web test is follow the manufacturer recommendation. However, for the non-web test, within CLI, it means about the moderate and high complexity of tests. This group of tests you may classify is into FDA approved, modified FDA approved, and in-house. For FDA approved, it's usually the commercial test that's already validated by the company. It means that this FDA approved test, you use the company instrument, company reagent, all the set that validated by the company. So what you should do is about the verification or validation is about the precision, accuracy, and you may do about the linearity and reference interval. For the modified FDA approved, it's been that you use the FDA approved, but you modify something, such as you may use the company instrument, but you are not use the reagent that validated by the company. So this means that you modified it. So what you have to do is a bit more than is required in FDA approved method. And for the in-house, this is a group of tests that you create it in your laboratory or the home brew. So what you have to do in modified FDA approved and in-house is almost the same, but the difference is when you do in-house, you have to do a much more number or a full validation technique. For modify, you just do more than FDA approved, but you can do lesser number when you compare with the in-house test. About the uncertainty of measurement, because of medical laboratory are classified as clinical laboratory. So usually for the uncertainty of measurement, we will do the top-down approach. And the top-down approach involves the internal quality control, external quality assessment scheme, or proficiency testing, and maybe involves the reagent lot, method validation or verification, and your calibration. And for the key point number 6, I would like to talk about the specimen management. That the importance of the specimen management is about the identification, correction, and handling, and also the transportation, reception and rejection, preparation and processing of your specimen, and your storage and your disposal of your sample. And key point number 7, this one is quite big, is about the analytical quality control. In analytical quality control, you will deal with a lot of topic that is the technical one. It's about the analytical method and principle, the internal quality control, external quality assessment scheme, proficiency testing and alternative assessment procedure, laboratory performance, comparability of examination results, etc. And this is the example of the quantitative test when you do internal quality control and external quality assessment scheme. For the internal quality control, you deal with about the precision control. For the external quality assessment scheme or proficiency testing, you are dealing with the accuracy control. For the precision control, usually you have internal quality control to help you to do this one. And usually you do the 2 levels of control. It might be level 1 and level 2, or level 1 and level 3. So it depends on your choice. And what here is the QC have to be passed. It may be even passed by the single loop or the multi-loop, but it has to be passed before you report the result. So if your QC out, you have to fix the problem and run the QC again before, and when the QC in, you can report the result. So you cannot report the result as long as your QC is out. So this is the concern that you need to understand. Also, the interrupt comparison. Usually you participate the external quality assessment scheme or proficiency testing and getting the bias. However, not all the tests that you can have the program. It might be a very new test or even the dangerous that you cannot get the PT sample. So you can go to the alternative assessment procedure, and this detail of alternative assessment procedure you can read more in QMS24. However, the example like a split sample procedure or even analysis of manufacturer calibrator or quality material. And for the laboratory performance, and this is just the example for the quantitative test. So when you do the precision, what you get is about the standard deviation and percent CV. And when you do the accuracy control through the PT, external quality assessment scheme, or even the alternative performance procedure, you will get the percent bias. And by the getting the percent CV and bias, you can calculate for the sigma metric by this formula. You can minus allowable total error by bias and divide it by percent CV. And you will get the sigma metric that might be 6 sigma or even just only 5, 4, 3, 2. It depends on the laboratory performance. And also, you may go deeper about the quality goal index by divide bias by percent CV. Usually, we use the 1.5% CV, and you get the result. And the result, if is less than 0.8, usually the problem is come from the imprecision. And if more than 1.2, usually the problem is come from the inaccuracy or your bias problem. So if the result is between 0.8 to 1.2, it might be imprecision or inaccuracy. The point number 8 is about your laboratory information system. It's important that you have to do the LAS management and maintenance, and also important for you to do the validation or verification of the software. What you put into LAS and what you get from SIS have to be the same. So you have to verify or validate this. And also have to think about the authority and confidentiality. So you have to have the passwords and also have to have the user cards. So it's for your consider. And also you have to think about the patient data management. And exactly you have to be careful about the data stability and security. For the 15190, because of there are a lot of requirements in this QMS, it's about the 16 requirements. So for your easier, I just classify it myself into 4 classification. One is about the structure. It will match with the requirement number 4 about the designing for safety. Requirement number 10 is about emergency preparedness and response. Number 11 about the fire safety. And for the safety management, number 5 is safety management program. 6 is hazard identification and risk assessment. Number 13 is about equipment safety. Number 16 is about transport of sample and hazardous material. Number 17 is about waste disposal. Number 18 is about the incident, injury, accident, and occupational illness. And for the hazards, number 7 is about the biosafety and security hazards. Number 8 is about the chemical hazards. And number 9 is about physical hazards. For the personnel, you are going to involve about the requirement number 12 is about the laboratory ergonomics. Number 14 about safe personnel and work practice. And number 15 is about the personnel protective equipment. So go a bit deeper to the issue to concern in 15190. I just pick up some important point for you, such as the when laboratory is constructed, an appropriate building code containing architectural safety standard for laboratory shall be followed. Ensure that containment of microbiological, chemical, radiological, physical hazards is appropriate to level of work area. And corridor and passes to the exits are clear of obstruction, and personnel shall be trained to potential risks associated with their work, and vaccination policy shall be implemented as part of health program, and personnel shall have immunization to prevent exposed infection associated with their duty. Safety manual shall be available for all employees, and safety manual shall be in accordance with the safety policy, fire prevention, electrical safety, radiation, chemicals, biological waste hazards. Safety program shall be reviewed and audited. Personnel shall be trained to fire prevention and control, and design personnel trained in first aid, and the first aid kits are available in laboratory area. Laboratory safety officer shall identify and document hazards, and all hazards shall be managed. And assess and prioritize risk shall be done in suitable methodology. All personnel shall be trained to use the biological spill kit. Flammable, corrosive, chemical, radioactive, carcinogenic, toxic hazards shall be managed properly. An appropriate gown, glove, PPE shall be applied, and gloves shall be changed between patients. And footwear should be comfortable, protective, and appropriate with risk levels. And waste disposal shall be managed properly. So this is all the issue. Just pick up some important point for you concern. And the key point number 10 that I would like to mention here is about the laboratory safety officer. This one must be trained to have the knowledge to manage all aspects of medical laboratory safety. So laboratory safety officer is the one who have to deal or even set the safety policy, the safety standards operating procedure, safety manual, safety guideline, risk management PPE, safety data sheet, waste management, safety monitor, safety continuous quality improvement, risk reduction, safety training, and he or she should be a member of safety committee. So I think all I mentioned you is about the 10 key points that's very important when you try to implement the 151X9 and 15190 into your laboratory. And I have the take-home message for you before before I finish my presentation. The take-home message is what you hear today is just some important parts of ISO 151X9 and 15190 requirement. And if you are the beginner, please be reminded that there are still many things in ISO 151X9 and 15190 that must be read. And I think you should read the ISO 151X9 and 15190 requirement carefully and several times. And before and be reminded that one who pay the auditor law should be trained ISO 19011. So it's very important for the ones who be the auditor. And I think the last thing that I would like to mention here to encourage you and to give you, encouragement that QMS is not hard as you think, because all things are difficult before they are easy. And this quote is quoted by Thomas Fuller several hundred years ago. And I hope that my presentation today will be useful for you and also can make you more confident to implement 151X9 and 15190 into your laboratory. Thank you for your kind attention. Thank you very much.
Okay, thank you, Professor Noam Pan. And seeing quality control is one of the most important tasks in the daily work of the laboratory, and is a systematic project to increase our quality control level. I think maybe you have some questions about how to strengthen laboratory management. Now let's enter the Q&A session. We collect some questions from the chat box. The first question, according to CLSI, is there a list of valid tests and non-valid tests? For this non-valid tests, if the machine system with same brand instrument and reagent can help laboratory save lots of works in method verification. Could you answer this question, Professor Nawapan?
Yes, thank you very much for this question. Before answering this question, I think we have to make the understanding that CLSI is the institute that are in the United States of America. So the system of web test and non-web test is a system that they practice in USA. So in different countries, you may have the different thing that might be not are the same. However, it can be applied if you want to do in your country. So come back to the question about the web test and non-web test. Usually web test, when you do the marketing in USA, you have to submit all the documents and detail of the test or instrument to the FDA to do the approve or the clear. So they have all list of the tests. And what is the web test? Web test is a test that very simplified, easy for people to perform the test. So even non-laboratory or laboratorian person also can perform the test. And the test have very less effects or make any very less serious to the patient itself. So there is a list of the web tests on the FDA website. Just go to the website and you will find them. However, for the non-web test, it's about the tests that are moderate and high complexity. And all these tests, because of I already mentioned that all the tests that you sell in United States of America, you have to submit detail to the FDA. So it means that FDA have all test lists. So they do not provide the list of non-web tests. But if you would like to have it, you can go to the FDA for ask that, because there are so many tests in non-web test list. So this is about the web test and non-web test. And for the question that you're asking about the for the non-web test that are moderate and high complexity, And if you are using the system that submitted by the company, that they do a market, which they do the same instrument, same reagent, calibration, that they submit detail because of their study already to the FDA, and FDA approve according that document and that evidence. So it will be very easy for you because it's already validated. So if you use all the system that you are not modified, so it's easy. You just can do only precision, accuracy. You may do linearity or reference verification. You don't need to do the reference interval estimate. That difference from if you go to using the FDA and modify it, that's going to be a little bit hard for you to do the validation or verification, and especially if you do in-house test, that's going to be very detailed because you have to do the full validation for the FDA to approve. So this is the details that all about the system that practice in United States. So in some different countries, it might be different from this. So this levels of complexity is practiced in United States. I hope I answer your question.
Thank you, Professor. I think this is a systematic project, as I mentioned. I think maybe they need more time to develop the right way to good laboratory quality control, step by step. Okay, and we collect the second question from chat box, and the question is, how do you compare the requirements of ISO 151A9 to the CLSI requirements? Could you answer this, Professor?
We have to understand this is a different system. CLSI is something you practice in United States, but ISO is a requirement of the system that in fact, if we go back to around the worldwide to the second worldwide, there is a ISO system first start for the commercial, and then developments of the ISO for so many things until we have the medical ISO. And this is the concept that we want to have practice something in the same way for the ISO. So when you do the ISO, the document is very important, that you have to write what you do and do what you write and keep do it as you written. So this is the concept of ISO. So every time you do that, you will do it in the same way. And you have to add some detail for the professional, because this is a medical health side. So you have to add some professional knowledge into that practice. For CLSI, it is a organization or institute in United States that they written a lot of regulation or professional knowledge for the people to study, to understand. So there are a lot of CLSI documents that you can find in the CLSI website. But that one, there are a lot of detail, like example, QMS24. That is documents about the alternative assessment, performance, or procedure. So that is just specific, but they have a lot of detail. You can have chemistry, you can have management, you can have microbiology, you can have even statistics for the CLSI, but it's a lot of detail. So you can use some knowledge from CLSI add to the ISO, because ISO do not provide or give you the details of the professional practice. It depends on your country and also your law and regulation in your country. So it's a different thing, but they can go along very well to use it together to improve your quality in your laboratory. Hope that I answered the question.
Yeah, I think we can understand in this way. One is the target, our quality control target, and another one to help us to understand the way, the road, the path to the final target.
Yeah, CLSI is like a tank of knowledge. You have a tank of knowledge of everything about the laboratory. But ISO is like a system for you to implement into your laboratory to get the accreditation. So this is a bit different, but they go along together.
Okay, thanks for your explanation, Professor. I think your presentation is very wonderful and help us understand the quality control system and how to achieve a better quality control in our laboratory in the future. Thank you, Professor Nawampa. I think this is the last question because of time limitation. We will move to the next part. Thank you, Professor.
Thank you. Thank you.
Okay, the third part, the third topic is clinical chemistry case study. This time we will discuss carryover. As we all know, carryover is the main factor leading to abnormal results. It may come from endogenous reaction, operation, and the equipment itself. As a persistent manufacturer, Mindray is committed to design more optimized and intelligent chemistry systems to help laboratories reduce carryover. The purpose of this event is to collect and share the identification and resolution of carryover cases. We are going to sum up the experiences which may help us reduce erroneous results caused by carryover. Now, let's move to the first case, which comes from Mindray application engineer. Welcome, Celia.
Hello everyone, welcome to attend the webinar today. This is Celia from Mandarin IVD Clinical Application Department. As we all know, carryover is a common issue that each laboratory faces during routine clinical sample testing. And today, I'd like to share two real carryover cases. Case 1 is about creating ACE and chloroform. Case 2 is about creating ACE and LB. Through these two cases sharing, I'd like to share some troubleshooting ideas with you to reduce the false results caused by carryover. And firstly, we can look at the definition of carryover together. What is carryover? In clinical chemistry testing, carryover is residual substances are carried to the next biochemical test through the instrument part, including but not limited to probes, QAs, mixers, pipeline, etc., with resulting in significant deviation of the testing result. If we divided the carryover by contaminator, it can be divided into sample carrying contamination and reagent carrying contamination. And if we divided the carryover by instrument part, the carrying contamination can come from sample probe, reagent probe, mixer, QAs, pipeline, etc. This is the definition of carryover. Next, let's look at the cases. Here is a customer complaint we received. The QC result of creatine A's is not stable. It shows a significantly declined tendency in 5 days. It changed a new creatine reagent. The QC results is good firstly, but 7 days later, QC results out of control again. They want to see the solution from us. And as you can see, we did a troubleshooting on this case here. Firstly, we made an issue confirmation. We checked the QC data from end user, and the QC result was consistent with what the customer complained. Then we made a parameter confirmation. Creatine test on BS2000 use close reagent parameter, and the carryover pairs has been defined already. Next, we made a confirmation on maintenance. The log file shows a good maintenance record. They have done the daily maintenance and weekly maintenance regularly. Finally, we made a confirmation on system. The QC results of other chemistries are good, and the system state is stable. Here is our verification on repeatability. We tested each chemistry on each sample, and the CV% is less than 4%. It shows that this analyzing system has good repeatability. Until now, everything seems okay, right? So we did a further verification. Because we have double checked the carryover pairs again, and all carryover pairs are set correctly and no changes are made. But when we checked the creatine A's on reagent carousel, we got an important information. The operator has changed the reagent position of the group-1, and the reagent creatine A's is next to reagent group-1. Reagent group-1 is a third-party reagent. Operator changed the position of group-1 reagent 1 on 28 January. Before this time, reagent creatine A's and reagent group-1 was far apart. Soon after, the QC result of creatine A's shows a significant declining tendency. We are seriously adopt it was contaminated by group-1. Here we made another verification on that. We load a new creatine A's reagent R1 on position number 4, and take out group-1 reagent R1 and run QC 2 times continuously for QC level N and QC level P, calculated the average, and the results are as follows. As you can see, the CV is less than 4%, and there's no obvious downward change. We can look at another further verification. Then we load a new creatine A's reagent R1 on position number 4, and load a new creatine reagent R1 on position number 3, and run QC 2 times continuously for QC level N and level P, calculated the average, and the test results are as follows. As you can see, there's a significant change on day-to-day differences, and the volatilizations of reagent group-1 reagent increases may cause the QC result to decline. So we load a new creatine A's reagent and remove the group-1 reagent, monitors and recorded the QC result for 1 month. The QC result is good and more stable finally. So the issue was solved. So this is the case 1. And for the case 2, as you can see from this complaint, here is another customer complaint. The creatine result were not consistent with urine results. The result of rerun is significantly different from initial test result, and there's no regular performance. So it is reagent carryover. And we also found it is on test on BCIAU open system instrument is Chinese brand reagent. So that is all information that we got now. Here we want to find the reason. Firstly, we check the instrument module item assignment and list all item testing together with the creatine test. And then we look for suspicious item according to agent testing sequence. Here we have found 4 items were likely to contaminate creatine test, and ALB reagent was the most likely one. So we made another verification test. We said different item group to identify interfering items. For control group, we run a single item creatine separately. For other 4 groups, we run creatine after each item and then get the result. After analyzing the data, we have found an abnormal result from group 1. Until now, we can make a preliminary judgment that ALB reagent has a positive interference to creatine test. So, next, we have tested 10 different samples for verification. Firstly, this table we can see the relative bias percent is obvious. This one is obvious. And after we add a spatial words between ALB and the creatine test, the relative bias turns smaller. It was confirmed that ALB reagent has a positive interference to creatine test. And after modified the ALB reagent testing sequence, the issue was solved. Because recently I also received some cases that complained ALB contaminated creatine. Here are some 3 main reasons I'd like to share with you. The first one is residual ALB reagent on probe could react with the next sample. ALB reagent is a single reagent. The reaction could be occurred immediately after adding ALB reagent in sample. And the second, absorbance peak of creatine A's and ALB reaction have overlapped part. As you can see, this is overlapped part. Creatine A's primary wave is 546 nanometer. But for ALB reaction, both have higher absorbance at this peak. And the third one is for creatine A's reaction has a weak absorbance, so it is easy to be influenced by other items. Above is why ALB reagent could contaminate creatine A's test. The third part is about the troubleshooting idea sharing. This is a routine method we do troubleshooting for carryover issues. When we receive a suspected carryover issue, there are 4 questions that we usually ask. Is it open system or closed system? Whether the system has a good repeatability. Special words have done or not. Is there any abnormal options or changes? From the side of open-closed system, we are going to confirm whether there are third-party reagents and whether all the carryover pairs are imported from default item file. From the side of system repeatability, we will be check the instrument parts and observe sample result and QC result. From the side of spatial watch, we are going to check the frequency of spatial watch and whether the fluid flow of washing solution is sufficient. For others, such as whether reagent testing sequence changed, testing volume changed, or etc., to find the real reason as possible as we can. You may have a question that why we put the confirmation of the system is open or closed at first, and I will answer it next. Because there are many difficulties to minimize carryover for open system. First one, from the side of reagent, if the reagents are from different manufacturers, it is very difficult to determine whether there are a contamination between reagent items through the reagent manuals. Often it is only relying on experience and abnormal results during sample testing to find a contaminator. Next is about the variation. Completely traversal carryover evaluation of all chemistry items need to be carried out before the testing systems start to use. But the workload of this job is huge, and it also demands that the laboratory operator to have a good understanding of instrument workflow. The third one, adding and subtracting items will change the testing sequence of items, and it may also bring new carryover. Furthermore, I want to share some solutions that reducing carryover or managing the system. From the side of the agents, we are removing the source of pollution as much as possible, such as modify the reagent formulas and remove the source of carryover. The second one is from the side of instrument. We are going to improve the instrument cleaning capability to cut the way of contamination, such as enhance detergent cleaning temperature, pressure, flow, and etc. From the side of evaluation, we are going to do more complete fully traversal reagent carryover evaluation. Found agent carryover pairs of each instrument model. And from the side of the test process optimization, on hardware, we are going to improve the smoothness of probe, mixture, two-way surface, etc. And on the software, to build carryover pair inconsistent software and aid enhanced work between carryover tests to optimize the test sequence intelligently. So if we can use closed system, it will improve the efficiency to reduce the carryover issues. Okay, let's make a summary together. First, for carryover itself, it is difficult in the detection. Usually, we need to do a lot of verification tests to find the reason. And we can improve the performance and reduce the carryover with optimized design and full evaluation. This is today's sharing. Thank you.
Thank you, Celia. I think from your sharing, we understand what's the important things for carryover. I think this one, as I mentioned, is very important in laboratory analysis, and it may be caused by a lot of reasons, but we recommend use original reagent and original calibrator can control. In this way, just like a serious analysis, we have enough resources to do better research and find out the carryover pairs and help our customers to set up the carryover. And also we have another case from India from Dr. Anuja Chopra. Actually, her case shows how the comparison pairs works.
Hello friends, I'm Dr. Anuja Chopra from Ahmedabad. I'm a pathologist working with precision diagnostics, and I shall be sharing a case of carryover with our Mindray BS240 system. Now, the system that we are using is Mindray BS240. We have an average workload of 35 samples per day, performing around 200 chemistries each day. We had an abnormal result. Now, the abnormal result was related to creatinine. Creatinine results were showing abnormal pattern while processing batch of samples. However, the precision during single assay showed a satisfactory performance. Erratic creatinine results were noted when a batch of samples was processed, and upon rerun of the same sample, normal results were obtained. So how did we come to the conclusions? As I've already mentioned in the previous slide, the abnormal behavior of some sample created a confusion. Due to the erratic behavior of one such parameter, we started rerunning all the abnormal assays that were performed and started looking out for the reasons. Now this is the data that we got. In the batch run, we got a creatinine value of 3.94, while the repeat run of the same sample as a single sample was 0.78. And similarly, the other samples were also giving such data. A value of 11 was obtained, whereas the actual value was 4. So this was a very scary thing. So root cause analysis was done, and we started looking out for all the possible causes. First, we looked at the instrument causes. All the other assays were showing satisfactory results, which meant the instrument was functioning okay. Reagent, we tried with a new fresh set of reagents, so the reagent end was okay. Operating procedures were scrutinized as per the protocols, and the protocol that we use, we were using the Mindray CreaTest system with an inbuilt program, so the protocol also was okay. Since no other reason was found, we started suspecting a carryover. And then we did a response curve analysis, and this is what we obtained. This is the first run analysis curve, and this is the second one, which is definitely more acceptable. Experimental validation was done with both of these, and a root cause analysis was done. And this is the precision check that we did with the same sample. So the precision check was perfectly okay, as you can see, and since it was all these samples were run following a lipid profile, we expected that there has to be a carryover from the lipids, primarily HDL, because that was the common factor in all these. So as a corrective action, we programmed creatinine to be run ahead of lipid assays, and then we put a carryover rule for the direct HDL. And it was in our instrument, we have put the rule as HDL is a contaminator for creatinine. Then we checked for any abnormal creatinine results. Repeat run was done, and we observed the system performance for 3 days and found all the results to be satisfactory, and hence the issue was resolved. So the take-home message that we get from this case report is that we need to be watchful with all the results, and we need to set limits or critical alert for rerunning the samples. We need to look for specific trends or common factors where unexplained random errors are observed. We need to rule out all possible causes before just pointing out any error as a random error. Reagents can have interactions, and we need to identify and separate such reasons. and a simple extra wash does resolve many problems. Many thanks to the Mindray team for supporting the laboratory for troubleshooting. Thank you.
Thank you, Dr. Anuja. I think from your case, we can see how the carryover pairs and how manufacturer works to reduce the carryover. And also, we think it's very important to understand the reaction curve. We can find how reaction happens in the qubits and help us to find out more potential problems. Also, with Mindray, we will offer you the guidance how to read the reaction curve. If you use the original reagent, we have a lot of data to support the analysis. And we have the last case from Kenya, from Dr. Rosemary, and she will share us another case about carryover. It's not come from reagent, but it comes from the consumables. Welcome, Dr. Rosemary.
My name is Rosemary Wanjiro. I'm a lab officer, medical lab officer, currently working with Texas Cancer Center. My area of expertise and growth is in implementation of lab QMS, good clinical lab practices. My area of expertise or passion is chemistry, immunochemistry. You'll find me there. I'm not there, I'm not elsewhere. Anyway, yeah. Now, in our biochemistry section at Texas, we're using Mindray BS200. The reagents, the calibrators, and the controls are also Mindray. Yeah. On average, we're able to do 200 tests per day. That is about 20 samples, 20, 25. Now, some days back, our doctors would raise concerns that some of our results did not correlate with their clinical expectations and also presentations. This didn't happen to all parameters. We had some chem parameters like ALT, LDH, and also triglycerides. Now, what was happening is that the samples would really read high. Yeah. So on our side, we'd try the first thing you told this sample read this and I expected this. And doing a lab, the first thing is first check all the pre-analytical errors. Is it the correct sample and all that? Now, after identifying that it was the correct sample, would rerun the samples and the results would be very, very have huge variations, sometimes from pathological to normal. It seemed that the repeatability of the samples were bad. You'd find an ALT on a first run giving a result of 100, then the second run 45 units per liter. And it's the same sample, good timing, same personnel, same everything. You'd find an LDH on a first run giving a result of 300 units per liter, and then the second run 280 units per liter. Such huge discrepancy. Then do TGs, one triglyceride would read to 10, the same sample, and then on the second run of the same would give a result of 40 mg per dl. Now, we were like, we don't want to continue like this. We need to get the root cause of this, troubleshoot, do the corrective action, and also get a preventive action that in the near future, we don't have to face such concerns, of which they were legit concerns anyway. So we checked everything. Now in our system, the plant preventive maintenance was done, like the probe had just been replaced like some 3 months ago. Our precision studies for an analyte like LDH were okay. LDH had given a CV of less than 4%. is an acceptable run as per the clear guidelines. The reagents were new, they're not stayed. The cuvettes were new, but not like reused or such stuff. Our calibration was okay. Even sometimes we'd recalibrate, it would still be okay. IQC performance and trends were okay. Our LGs were doing well as per Westgard rules. Now, we decided to do a deep review of this like phenomena, and we found that the abnormal results had some common features. Some of them were like, you'd find that the second run normally is good. Only in the first run with mixed tests was it affected. Sometimes the LDH would be very high if the test is or was followed by an LFT. The other finding or feature we found was that the reaction response increased higher in abnormal first runs. Also, almost all the cases, the second run results were lower than the first run. For example, I've given the pointer and first run ALT 100, second run 45. That was it. And then you can see all the first runs here, the reaction response would be very, very high. So we went deeper to analyze maybe to check and troubleshoot, is it an instrument? Is it a reaction principle? Are they related? What is it that really happens? So we got to do an instrument analysis to check its, performance qualification. And it was okay. You'd find LDH calibration, like as displayed on my left curve, you can see the calibration is normal. On the right curve, there are three reaction curves, but there's first run and second run as shown by the arrows. You can see in the first run, it is really high, not even closer to the second run. That is what I was saying, like the first run's high, like high, not a high of 10 and 12, a high of, 10 and 50, yeah. Now, we got to the other thought that it may be from sample carryover contamination. But now how, and the probe is changed. And then the probe, we had a cleaner. So it's not that the probe is not cleaned. So we're querying, is it a manufacturer design problem, or this machine has just decided, it is not going to cooperate. So we were like, okay, instrument, okay. We did another analysis. The second analysis was, now we got deeper to the reaction principles of the parameters involved. And in our case, like for example, on an ALT, the method we use is a UV RC according to IFCC without pyridoxal phosphate activation. And you'd find that in the reaction path of how now ALT catalyzes the reversible transamination of L-alanine and alpha oxoglutide to pyruvate and L-glutamate, then the pyruvate in presence of LDH getting reduced with concurrent oxidation of NADH to NAD, then now the change in absorbance will be directly proportional to the activity of ALT in the sample. Now you can see in this reaction path, LDH is involved. So we would query, because LDH results were higher if they were preceded by an LFT panel. So we were like, could there be a chance that this LDH involved in this reaction pathway was carried to the next sample as as an issue of carryover, taken forward, and that's why now the LDH will be higher if preceded by an LFT, because the ALT and LDH, they have a way that they get to come together. Yeah. So we went further and checked, you can see in that picture, the analysis 3. Now, physically, the hardware part of it, the probe is okay as shown by the arrow. That's the sample reagent probe. You can see the mixer in the washing station. So, in other words, in terms of carrying over, everything is okay. Now, we got to seek, further support. It doesn't end with you. There's always one who knows better than you sometimes. So we sought help from the distributor engineer. But now no fault was found on site instrument checking. Like the instrument was okay. Everything, like calibration okay, instrument was okay. Now, the engineer noted that the detergent was not original. It seemed the quality was not okay, and therefore he recommended that we get a Mindray detergent and use and see. So we really wanted to fix it. So the second day, we procured a detergent. We received the detergent, and from that time, the issue is fixed. Like, it's not even, it's corrected, it's final. Because with continuous monitoring, we've never experienced such cases anymore. Therefore, it became so clear that the problem was a result of reagent or sample carryover from the dirty probe. This probe was dirty because we were using an incorrect detergent. Now, that's the detergent we're currently using, CD80 detergent from Mindray. Yeah, you can see it there as displayed on your screens. Now, carryover is very common. It just happens in our labs every now and then, and we should be keen to like realize it and at times fix it and identify what could be the issue for quality results and good, reproducibility, quality diagnosis and such. In this case, the detergent for a closed system is really critical in chemistry because this will enhance the cleaning effect of the probe and mixer. And it is recommended that we use original manufacturer consumables because they guarantee the system performance as per the manufacturer specifications. I think that was our case study, and we're happy we fixed it. Thank you. Yeah.
Thank you, Dr. Rosemary. I think you told us that's the importance to use the original reagent consumables. And thanks for your sharing. After the webinar, and maybe because now is COVID-19 epidemic season, after this, maybe we will try to find the opportunity to give you a small gift for all our customers who share the cases. And we welcome everyone in the future. We will have the second, the third, the fourth season. You're welcome to share your experience and the cases. And this is the QR code. This is a post surveying, and please scan this. Let us know your feeling and situation. Also, if you finish the information, also you can leave your question to the comments box, and we will send you the certificates according to your feedback. So that's all for this webinar. Thank you, everyone. Have a nice day. Looking forward to your next coming. Goodbye, everyone.